What's up? My name is Travis, and today I'll be showing you the toolkit function, square root of x. And if you plug it into your calculator, the function will look something like this. Automatically, I can tell that nowhere on my x nor my y axis does my function go into the negatives. Therefore, my x and my y have to be equal to or greater than 0. And by x and y, I mean domain and range. Equal to or greater than 0. And my x and y intercepts, it starts at the point 0, 0. So that's both my x and my y intercept. 0, 0, 0, 0. And since my function goes on and doesn't stop, it's increasing and not decreasing. Also because it never goes into the negatives. Now we move on to the chart. I number mine by 3s, 3, 6, 9, 12, 15, 18. You can number yours however you like. And 3 squared is 1.73. Actually, let me plug it into the calculator, make sure. Square root of 6 is 2.45. We all know that 9 squared is 3. Square root of 12 is 3.46. Square root of 15, 3.87, and square root of 18, 4.24. And what this chart is basically saying that whenever x is 3, y automatically has to be 1.73. Whenever x is 6, y is 2.45, and so on and so on, always. Now we move on to transformations. For starters, my graph looks like this, if you remember. That's my original. Now this side, we're going to flip vertically. And when flipping vertically, you have to insert the negative in front of the whole function. Therefore, my function would be negative square root of x. And when you flip something vertically, it's flipping along the vertex, the asymptote, or the center point. And my vertical flip will look something like this. It's like a mirror image vertically. Now, when flipping horizontally, you have to insert the negative in front of just the x. Like so. That will make a mirror image across the y-axis. And that's what it's flipping across. The y. Now these get a little bit challenging as you go along, as you get better at it. For instance, you can add 5 to the x. You can add a number rather to the x, or you can add it to just the whole equation. If you add a number to the whole equation, that's going to move it, that's going to move it left and right. Up and down, I'm sorry, going to move it up and down. To move it left and right, you have to add a number to just the x like I did here. So this is going to move my function left and right. And being that the negative is outside, I know it's flipping vertically. So this is going to look something like this. Plugging into my calculator. Like I said, you can use your calculator. I'm using mine. This is what that function looks like. And for this one, square root of negative x minus 3, this function will look like this. 3. And let me make the original one so you can tell the difference. So there you have the original, the flip, the original to this one, and the flip. Okay, and one thing my classmate Leslie pointed out is that the log function and the ln of x both look like my function. If you remember, my function looks like this. And as you can tell, mine has no asymptotes, which means it doesn't touch anywhere close to the y-axis or the x-axis, but doesn't touch exactly. The log function, however, plug it into my calculator, keeps going. In mine, it doesn't keep going. It stops right here at the point 0, 0. The log function goes all the way down, and it keeps going, as you can tell. The ln function has an asymptote on the y-axis, which means, like I said, it doesn't touch, but it almost touches. These are two common mistakes people make. So don't get fooled by the log function, the ln function, and my function. They all look the same, but mine stops at 0, 0. Log function keeps going but doesn't touch, and also the ln function keeps going but doesn't touch. So don't get fooled by that.